All right. Let me get started. So we're going to finish up on the, well, first thanks for the few that made it through the rain in class. Today we're going to look at the finishing up the lab 8, and then we're going to get started with the topic of the week that has to do with the statistical graphic. So let me share the screen. This one, right, that I want. Okay, good. Share, here we are. Okay, so I did change a couple of things, and maybe we'll go through that quickly. Okay, so this is the example 0. So I think I commented a little bit on what you need to do there. So this is basically loading SVG into the page using different methods. And I think you had the D3 here, way uncommented. Now, this is a little bit of one of the ways in which we're kind of tricking D3 into doing a job that is not really what it's meant to be used for. And so you need to do all these tricks to go and get the SVG, to load it first in a form that is basically HTML version of the SVG that you can readily set up inside the DOM tree. So if you go and look at the documentation, and I'll share this I'll share it here, and then I'll make sure that I share it. I'll share it in the chat. Okay, maybe if I can. Oh, it's on here. Okay, so these are some links to docs that you'll find in the chat, and I'll put it also in the Slack after the class. So the long story short, what we're doing here is that we're taking this SVG and importing it with D3 XML, and this is called a DOM string. And you can go and look at the documentation for the document element that I've linked here, and that it will explain you just that. So basically, it's a string that is that can be used by the browser to instantiate nodes if you attach it to the DOM tree. And so the way we attach it to the DOM tree is that we need to go and find here the node for which the SVG or the ID, this is the ID for the div where we want to attach it, is set up. Okay. And then I've linked also the documentation for node. This is because here, when we do the selection, what we get out is a selection that is not the node in the DOM tree. But we do need the node in the DOM tree because this append is not a D3 append. I mean, we're not doing appending to the selection. We want to append to the node, right? And what we append is the DOM strings. So I'll let you go and look at documentation for that. The other ways are basically plain JavaScript ways of doing it. So you can use the body append to do the same, or here we do a get element by ID. I think that we use that early on to when we try to do a small JavaScript library to do charts, which basically queries the DOM tree. This is a function that queries the DOM tree for a given ID. And then we do append child that does the same thing that the append child in the append in D3, where it appends the whatever you pass in argument as the last child of the element that is selected. And this get element by ID returns the actual node in the DOM tree, so that this is a function of the node. Okay. This one here, I've added also some documentation. I'll put it in here and also add to the Slack. So these are the, I'm listing them there because it's not immediately easy to go and browse the free documentation, or at least search for it for these things. So I'm giving it to you for this time, but obviously, depending on what you need to do, you may want to learn to go and search in the D3 documentation pages for these and others. So here, what is complicated is that if you go to the main D3, you'll see that the page is split with different libraries, and the projections are part of the D3 and so they're documented. So you need to actually go to that page to search for them, and there are examples that are given there on how you use these functions with the specification. And whenever you need to use any of these projections, that's the first thing to do, is to go and look up at the documentation to understand what they do. Because here, this Albers USA, if you don't know what it is, that's kind of useless. And this is the Albers projection. That is a piecewise projection for the United States. All right, good. So I think, yeah. So this, I think we saw it. So yeah, whenever you need to explain the gratitude, so you can go and look up the documentation first. So you understand what is available in case you want to use that. And I think we kind of stopped at this one. Was it the lab 6? Let me go there and then. So these are the solutions. So you see what it looks like. Is that? Yes, yes. Oh no, right. So yeah, you want to start in here, okay? Because otherwise the package.json is different. The top level package.json, we keep it for the homework. Yep. Okay, so this one we can close it. All right. Yeah, so here I did it, but I'll redo it as needed. I think we'll start with, yeah, this one actually we saw it already. So here we're just basically trying to project No, we don't project. We just use, we do a free proportional. Is that the case? It's not a proportional symbol map. This is wrong. It's a choropleth map. And let's go and look at the code. I think we reviewed it already, but we can go through it again. Right, so the data is in here. Now I put a link for the homework to the repository. So Mike Bostock maintains some repositories for the world maps and also US maps that are in topo.json format and that are already projected. I think some of them, or maybe they're not. So you may want to go in there and see which one is appropriate to use for the homework, because I think you need to do a map for the countries. So you need a world map, which you can get from the world atlas. I think is what it is. And yeah, so here you see that is the topo.json is not projected, so we need to actually no, it's projected because we're not setting up any projection, but D3 doesn't know how to deal with topo.json, so we need to go and use find the features first in the topo.json, and then call this function here that is the dot features that is going to return the GeoJSON features that then we know how to deal with in D3, right? So if you don't, obviously you can just console log this and you'll see that it's going to output a GeoJSON object where you have the features for the different states, right? The rest, I think, is we already looked at it last time. The 7, I think we actually got to the footprints. No, we stopped here, right? So we stopped here. So this is what happens when you want to do local maps, is that you need to find a repository where you can get the GeoJSON or topo.json for it. And that usually, that might be available, but it might not contain exactly what you want. So here, if you just care about the county, so this is the part that you want. You don't care about the islands. So here we're going to see basically how to scrape the GeoJSON from the Los Angeles GeoHub, that is the repository of data for the county, for LA, sorry. There is another one for the county that I think we're going to use in the number 8. And see a little bit how we can do some basic editing here to just narrow it down to the geometries that we are interested in. So here what you see is what you should get after you've downloaded the files. If you want, I can go and do it. Yep. So you should basically have all these files, sorry, these renderings in the page. So is it worth that I do it, or you're done with that already? I see people nodding, meaning I do it, or you're done. You're done. Okay. So let me see if okay. So if online you want me to go through this, then let me know in the chat. Otherwise, I'll continue with the following one. All right. So this one, yeah. So this is getting data from the LA County, and this is what you should see. So this is not so some dirt that is there on my screen, or it's the actual geometry that we see here projected. So I don't know what is wrong with this file. It's supposed to be the GeoJSON, but you see that this is not good. So what we're doing here is trying to basically resolve this problem. That is a practical problem that happens times often because either this GeoJSON is not formatted correctly or the file is corrupt. We don't know. But what we know is that the source of these GeoJSON files is 99% of the time a shapefile. So what we're going to do is we basically go back to the shapefile, which you can download from the same location, and then use different editors to convert it into the GeoJSON that we need. So the editors here is by no means the full list of the choices that you have, but these I think are practical for you to use if you need to do something specific for your project and or for mapping applications. So this auger here is an online one. So it's as simple as getting the shapefile. So if you go and download the shapefiles, you'll see that this is just a zip file, and I have it here. Where is it? Here. I've downloaded data downloads. Right. Can I do new reveal in Finder? Yeah, there we go. So this, okay, now this zip file, as you can see, is 3.5 megabytes. So don't add it to the repository because what we want is the output of it. But I wanted to open it. You don't need to open it to load it, actually. But I wanted to show it to you open so that you see what is in there. So now all these files are I think most of them are binary files because the shapefile is a proprietary format from ESRI, that is the company that created it. And so the geometries are in this .shp file. And then you have other files that tell you that this one is going to tell you which projection is used and so on. Okay. And people have kind of reverse engineered this thing. And they wrote some tools to basically convert the format to something else that we're going to use. So with Augur, what you do, let me go there from here, is basically you pick the zip file, okay? And you just hit the convert to JSON button, and that's going to give you the GeoJSON as explained there in the description under the Augur logo. Now you see also that this is using this OGR to OGR. So this is one of the tools that is part of a set of geospatial tools that people use for mapping. and this particular one, if you can go there, this is a command line, and you see it's kind of complicated to use. So the website basically makes it easy to use for you to run this tool without having to install it. Okay. So once you get the whoops, where is it? It's here? Here we go. Once you get the exported file, you need to go and look in the code to make sure that it goes into this location, and then the map should appear. Yeah. So I'm assuming that there are no, and the code again is just a code that we have seen already for with D3 to render the GeoJSON. Okay, the part number 3 here is about using another tool that is this shape to JSON. So this is a node executable, not unlike the one that that we've played around, I think, in Lab X, right? I gave you this little command line tool. And you see it does this switch here with -O for the output. So if you run it, so this node module is the one that we have in here. So let me open another. So here we're inside the lab. We should go inside the lab. And so you can just go and look in there with the set this shapefile. So it's part of the shapefile package that you can see is loaded here. And shapefile, so that there is a bin folder and shape to JSON is there, right? So for those who are not familiar with the command line, in Unix, you can just hit tab and it's going to complete, depending on which shell you have, it might look different. So yeah, so you don't need to type these things. You see that they have another tool in there, the DBF to JSON, DBF being another format. Okay, so once we have this, oops, shape to JSON, then we want to run -O, okay? And again, we're going to create, this means that we're going to create the file here. Obviously, you need to go and place it inside data for it to render. And okay, so this is assuming that you've put your shapefile here. But for me, I have it under this underscore downloads. Oops. Yeah. And there is, okay. Downloads, I'm going to get there. Okay, yeah, the file name is different for some reason. No, we want this one, and we want the shape file that is this one. Okay, and this works. So probably we have here the file that was created. That you see it's rather big, hence the usually you want to transform these things into topo.json, so to save some space. Yeah, so if we move it obviously in data, then you will see it. Yeah, I was thinking that I forgot to mention for the 0 example, Was that the map, the example 0? No, is the one. Example 1. Yeah. Now these and any other maps, right? You can pre-render them because these are static, right? So you can use them. So it's SVG basically that is created. That you know, if you want to add some interactivity to it, then you can always go and get the ID for the feature and use d3 to add the interactivity. But they're static in the sense that it's a static file, right? Now, where do you go and get them? So one option is to pre-render them offline, and then load them as we're doing here in the page. So how do you pre-render these things offline? One way is to render them with d3, right? And you save a picture out of it that is an SVG picture, right? So similar to this one. So if you go and look in the lab X, I think I gave a little, I don't remember if it's a tool or just code with Node to use d3 to do some offline rendering. So why is it offline? Because when you use Node, you don't have the browser. And so in order to render anything with d3, you need the DOM tree. Because d3 doesn't know how to deal with this, the functionality that it provides if it doesn't have a DOM tree to render into, okay? And so you can go and see in there what I'm doing is use another library that is providing a DOM tree that you attach to d3 and ask it to render. And then it will render into that virtual DOM. And you can save, I think that the example, I'm saving a picture out of it, okay? So this is more for the project if you need to pre-render maps, as opposed to, you know, because the pre-rendered maps usually are smaller than having to deal with all the GeoJSON and load it and render it. So it's going to render fast, and it's less data to get in the page. All right, yeah, so we're back here. So this one, I think we're through it too. Yep, yeah. So now the problem here is that you know, you get your GeoJSON. So if you want to edit it, you have the choice, obviously, to open the file and go look for some ID. And eventually delete it. And that's basically, so one way to do it is that you render it as we did in this one. Where is it? Here, right? So if you, here I didn't do it because I for some reason I already filtered it. But say if you want to remove this geometry, you can just go and get the details for the ID for this feature, and then you open the file and you just remove that feature, and I think it's more or less what I did here with the two islands. Yeah. So that's kind of the manual way to do, but then you can also use this tool here, the QGIS, to basically do the same. And I think I've yeah, I ended up doing this. Yeah. So yeah, and yeah, it's a little bit tricky because I think if you load the zip file, it doesn't work. It doesn't let you edit for some reason. You need to load the shapefile. So if you want, we can do it. So and this thing should work in Windows as well. Yes. So this is the old version. I installed the new one just to make sure that that it still works the same. All right. And okay. Okay. So let me see. I did it over the weekend. I thought I updated the instructions, but maybe not. New layer. Okay, so we're going to create a layer with. Okay. Okay, so I think this is the way to do it. I'm going to give it a shot. So first we create a layer. So maps are basically set of layers. In each layer, you can have some features, some geometry, right? So we just create one. Oh, okay, file. No, okay, okay, no. But then it's just opening. No, okay, okay, we'll see. Let me try. Oops, sorry. Equals. This is okay. Okay, that's what I thought. You cannot open it like this. Okay, so when I did create a layer. So let me go. Okay, I don't know why, but I don't remember doing this, but let's try. Oh, okay, so this is it, okay. I didn't remember. Okay, so you want to create a layer and then you select the shape file and I think you just say add and close. And we have it here. I might have added it twice. And then if you want to edit, you need to make it editable. Which I don't remember how you do. Oh, here, toggle editing. And then you need to go in selection mode so that you can select these things. So you can use the eye here to identify features, right? And this is the information that is in each one of the features. So there is an object ID, etc. Right? So this one is an incorporate. Okay. I don't know. I thought the Catalina had actually. So there are two pieces in Catalina now, right? But okay, it shows unincorporated. That's fine. And how do you? Okay, so the toggle editing, you can access it here too. And what we want is to select edit, select features here, okay? That I think is available in one of the menus, but okay. And then you can just drag over, and if you hit delete, yeah, I created two geometries actually. Because I added twice. That's why. So right. Oh, okay. So you see that I created two, right? So we have two layers. So this is the second layer. Okay, I remove it. Yep. And then you can export this. That is somewhere in here. Export. And we want to export the layer. No. Maybe save as then. Is that what I put in the help? No, it's not the save as. Layer toggle editing, okay. Export the right click on the layer, then export, save as. Right click on it, export, save as features. Okay, so it's here. And you see that the format comes up as a GeoJSON, and that was what we wanted, and now I lost it. GeoJSON is here. And you just need to give it a file name. Okay. And here is going to do the right thing, because even though I loaded twice as two separate layers, you export by layer. Okay. And this is because GeoJSON doesn't understand layers. GeoJSON is just one set of geometries. It doesn't know about map layers. And I think you just do this. Yeah, so this is probably because I don't know where I'm saving here. Okay, let me retry. Yeah, so you see I'm in the system here. So in the desktop it should work. Okay, so this will work. Yeah, you see it's taking a bit of time. So eventually you can just use this GeoJSON and it will work as you expect. Okay, so to resume, you need to go into layer, create layer, oops, add layer, add the vector layer, and then you can point to the shapefile and you're ready to go. I don't know if people have done it in a different way. Maybe there is a different way, but that's the way I found how to do it. Okay, and this we don't want to save because it is saving basically this project with the different layers there that we don't need. Okay, good, it's gone. Yep, no question about this one? Okay. Okay, 9. Okay, 9. Okay, so this is another. Okay, so here we're looking at the city boundary map. So here the subdivisions are based on the city for LA County, and what we're going to do is take the GeoJSON that we got from QGIS, and that should appear here if you put it in data already. No, if you click, actually, you can you see the. I've implemented this in D3, so you see the properties for the different objects. And we're going to play around with projecting the geometries in the GeoJSON. So the D3 has the functionalities in D3 Geo to deal with features in GeoJSON format and projections, but they also have server-side tool that you can use, that is slash library, that you can use on the server to do exactly what we're doing, that is to project things, so that then you have a GeoJSON that is already projected and you can put into the map. Yeah. And this I'm loading in here with this guy here, the TopoJSON server. I think, no, maybe not. No, the TopoJSON server, no. So this is just for TopoJSON, right? The D3 Geo has already an executable that you can use for doing the projection. That is in the bin folder. So again, we can just go and look at this one. That's right. Okay, so you see that the tool is there, and if you want, we can see that it's just a node executable, not unlike the others that I've been showing you. You see that they're using Commander. This is for the command line options that you see here. And then obviously it's using the D3 Geo libraries for doing the projection and all the rest of the stuff, right? So there is no mystery in there. So, but it's just a handy tool that you can use to process GeoJSON files. So the slash here is just means if you can paste it as is in the command, but I'm going to put everything one on the same line, so we'll see what we're doing. So this piece here is the what we want to do, and that's the first argument that GeoProject wants. That is that you say what is the projection method that you want to use, and it's actually the code that we want to execute, right? As a string. These are the operators that you can use on the command line. This is for the input operator. So what the command line is going to do, if we just put this in like this, and this out, and obviously it's not going to work because this file here is in data. Let me see if I can use the arrows. Yeah, I think it's in data, should be in there. Okay, good. You see, I removed one character and just it tabbed to make sure that it completes it, meaning that the file is there. So here, what the command line is going to do, maybe I can make this a little bit bigger. No. This way, yeah, is this way. Okay, good. What the command line does when it sees this thing is that it's going to load the file and put it on the stream and feed it into the program. This is called the standard input. So the program can read from the arguments from that come as you started, and those are the runtime arguments. but then it can you can also say that you want to read from the start-done input and write to the standard output. That is what happens when you put the greater sign. So the output is going to go into this file. If you don't put it, we're not going to put it, so you see what happens. Yeah, it just writes it out. Yeah, it writes it out. But if you want to pipe this into redirect, this is called a redirect into the file name that we're going to call out.geojson, then the output goes in there. Yeah. Obviously, it's faster to do this because writing all this stuff in the console takes forever. So yeah. And then if you want to take a quick peek at it, you can use the less to look at it. And I think if you use the slash, you can search for city, for instance. Okay, there is no city because it's only capital. Yeah, there it is. Yeah, I think there is a way to search case independent, but I don't remember what's the shortcut. But yeah, obviously you can just open these files. And again, to exit, I think to exit you type Q with the less. And I think if you have the code, this might work. It opens a different one. Okay, too bad. Because I added, yeah. This is the one that I have opened for the lectures. But you're right here. Because this is JSON, if you want to format it, you can. Oops. Yeah, you don't type Command Q, but you type you select everything and then you format the document. Okay. I need to restart it, sorry. Because I quit. Yeah. Okay. And obviously it takes forever because it's loading. Oh yeah. Format document. It looks like it's doing, but yeah, maybe not a good idea to format. Okay, just taking forever. Normally, the Visual Studio Code recognizes the extension as being a JSON. Yeah, at least is what it says here. So I think it's formatting, but it's taking a long time. So maybe not a good idea to do this. Okay. So let me instead join it and just reopen the. I think I saw the solutions here. Okay, so the lab. Okay. Sure. Okay, this import. That's good. So this is going to work. All right. So I think we got the step down. The topo JSON. So So the idea here is that we want to cut on the file size. So the topo.json server that is this node library allows you to basically do the transformation from the GeoJSON to the topo.json. And this is the command line. So I think this is straightforward to do. So you shouldn't have trouble with that. And as soon as you put the output into the data, then this is what you should see. Now projected, so here the code obviously is going to, if this is not, yeah, this is not projected, so there is the projection in the code that needs to project to change the topo.json to GeoJSON and then project the GeoJSON so that we see it in the page, right? Here what we're trying to do is to encode the projection directly into the file. So the coordinates are going to be pixel coordinates as opposed to long lat, right? Yeah, so there it's basically the same process. I'm a little bit surprised that this is the same. Is that the same? That's the same. Okay. Oh, okay. Yeah. So what is? Yeah. So here, what you want to do is to use the projected GeoJSON from the previous step, right? To get the projected topo.json, you first create the projected GeoJSON, and then you use it with geo to topo to generate the projected topo.json. Is that good? Yes? Yes? Okay, good. Actually, that's right. Yeah, yeah. Okay. So this was corrected. This was correct. Okay. I was looking at the wrong one. Okay, the last one here is just to look at the printouts. So you see, we did this one. I'm going to redo it here. Yeah, okay, that should work. No, cd lab. Okay. And yeah. So you see that if you go with the topo.json, you're cutting quite a bit, right? About half the size of when you just go with the GeoJSON. And 12 megs here seems to be quite a lot. So then depending on which tool you're using, you see that it's a little bit different. Yeah, the projected, this one, I don't know where we got it from. So it might be that we started from the 11 megs. This might be the projected version. No, it is not, because this is the projected. So we started from here. So we started from 11 and we go down to 9.8. Yeah, because we're still with GeoJSON, but as soon as we move to topo.json, you see that this is a little bit smaller than what we had here with just the regular GeoJSON. So yeah. All right, so let's go to 10. And I think we talked a little bit about it. So maybe we'll look at the code if you want. But these are basically running examples with D3 that I think they're taken from the old website. So they're not from observable. But some of these have been migrated into observable, and you can obviously go and scrape it from there. But here the point is just to understand a little bit how things are done with D3. That is similar to what we've seen for the layer that includes the map. But here we have on top of that an added layer for the data. And the layer for the data is just a bubble map. So you remember from class, you have a couple of ways to get the data in the page. One is that you encode the data as part of the GeoJSON on top of JSON. And you can use the properties for that. Or you can use, in GeoJSON, you can add whatever you like as key property values in the features. And normally, because you're using D3, you load it as regular JSON, so it's not going to get filtered out in any way. So in there, you can attach your data in that way, right? The only problem is that you're making some dependency in the GeoJSON file. So any software that is meant to display GeoJSON will not render your data if it doesn't know about it. But that's basically the only drawback. The advantage is that you get one file as opposed to a data file and another file for the map. But sometimes it can also be an advantage, because if you have a base map and multiple data sets that you want to show on the same map and switch between the data sets, then you probably are better off by loading them independently. Now because there is the projection that needs to happen, right? The base map is in a certain projection. If you have at any rate, you'll probably want to match the projection that you're using for the base map for your data. Otherwise, you need to do something specific in the code or reapply the same projection. So if you use unprojected data, then you should use an unprojected map, so that you just set up your projection and project everything. If your base map is projected, then you're better off projecting your data. So your data should be in pixel coordinates, so you can just put it on screen without thinking too much. Yeah. So we can take a look at the code, I think, but this is really what is important to keep in mind. I think the last one here is the choropleth. Yeah. So this one you see is a little bit complicated. There is a scale, so I think that in this example, yeah, they're using this thing that is a color legend library for D3. So you don't need to go and set it up from scratch. And then in terms of the map, you see that this is similar, at least for the states, to a map that we've done in the examples early on, where you see the boundaries between the states, but there is no external boundary, right? And there is this rule that you need to implement in order to do that. You can go and look up in the example, and that's something that is obviously used here as well. The other thing is that you see that here they have, I think these are counties within the states. And so obviously the data that they have is per county. And the counties, they have single boundaries, right? So that's a lot of data. I think this one is using GeoJSON because of that. And if you want, we can take a look at it. And I think that the data are also encoded in there, or maybe not. I think one of them has the data encoded, the other one not. week10. Okay. Yeah, so you see here what we, so there are different ways to do this. You can nest the D3 calls to get the base map and then the data, or as here, use the promise all. And you see it's as simple as saying for each one of the files that you need to load, you set up a promise into an array, right? So we just use the push here that is pushing an item into an array, where promises is an array that is here empty. And each one needs to do a call to d3.json. Yeah. And then you just do the promise all, and the output is this values array that is made up of, it's an array of arrays where the subarrays are relative to the index for which the data is set up in the array of promises. So here the values of 0 corresponds to this data set, and values of 1 is what you would get by running a d3.json on this JSON file. Okay. So that's for it. So here we have it different. So here the challenge is to basically relate this JSON file that has the data to the geometries of the map, right? And so, not surprisingly, it's what is done here, where we're looking. So a map object, you can go and look it up. Is just we're doing a lookup map basically for the state, so that we can go and query it when we need to add it to the map. And this is where is the map that is used? So this is for setting up the legend that is this one, right? The legend is done because this is proportional symbol. So this is a neat way to show the proportional symbols here with the concentric circles. They're not concentric, but they're aligned at the bottom. And that's the code that is doing that, setting up the radius for those circles here. And you see that they're using D3 quantile, that is the quantile scale for that. And these are just the operations on the arrays and some parameters so that it comes out as you would expect. Now, this way of writing JavaScript here, where you put everything nested, etc., is kind of typical of what you would do in notebooks, except that here it's just for conciseness. But obviously, the way you interpret this is that if you want to understand this, that you look at the inner part and then move out little by little. So here is the D3 quantile that takes this 2 arguments. So you need to go and look up in the quantile scale what the first one and the second one is. This is a way of this is an operator that we haven't seen much I think, in JavaScript. That is to get basically here we're building an object with data from another object, and the data that we're interested in are these values. And so this operator basically extracts it from the object and lists them in there. So we could do this with a push, but this is more concise way of doing it. And again, you can go and play with the command line with those to see what is the output. Yeah, so you see also that here we're sorting these values. So here, basically what we want to do is to get the 3 circles, and we want them to be sorted in order. And so they're sorted in ascending order and so on. Yeah. Over here, okay. Yeah, so you see here we're using the map. So on a map you have set and get functions. So the set function they were done up there where we created the map. So here we're getting for the current feature ID, we're looking up in the map for the data that corresponds to that ID, so that we can do the data join. Yep. Yeah. So this is the 10, and we can take a quick look at the 11, and I think okay. So the 11 works more or less the same, right? So you see that here we don't have this array of files where we just go there directly. Yeah, I mean the previous one we could do it because you see here the data are in CSV format, and then the base map we need JSON. So in the first example it was always JSON, so we created an array of files and then mapped it to diff.json. That was straightforward, but here it's faster to just write independent lines, and it works basically the same. And you see that here also we're using a map to do these things, to do a lookup map so that we can go and query the data as needed. Yep. Yeah. So these examples, obviously, you can reuse them for the homework. The homework, probably you need to do different types of maps. So the files that you load in the projection, etc., are different, but you can basically reuse some of this code as needed. Okay. So we do a quick break, and then we move on with the stats. All right, so we're going to restart. So for those who are in Windows, when you, yeah, maybe I'll do it on screen so that it's easier to see for everybody. So let me stop this. Yeah, this is the lab. So I'm going to, yeah, I think we can stop this one. Yeah, we can stop this one. So when you need to run an executable file, say from node modules, script files. No, are we at the right page here? Oh, okay. I'm in the wrong place. Okay. CD. I think I already closed the window, so give me a second. A8. Okay. CD lab. Okay. ls node modules shapefile bin and shape.json. Okay. So if you want to run this in Unix, such as here, then what happens? Oh, okay. Yeah. Sorry. I thought I was sharing, but I'm not. Okay. Here. Okay. So when you run a node script, let's look at this again. What does it make work in Unix is the first line here that uses this env that is a tool that is going to basically start this an interpreter to parse this file. And so here what we're saying is use node to interpret what follows. Okay. Now this is the path where this env tool is that doesn't exist in Windows. And so if you try to run this script in Windows, what it seems it's doing is it's just showing you this file that is not useful. But if you installed Node, all you have to do is basically run the Node executable. And if you look at the help, it will tell you that if there is a file, a script file, JavaScript file, an argument, then it's going to load it without further question. So you just need to basically prefix the command that you would run with Node. And this you can see it with the help, where it says just that right at the top of it. Here you see you can run Node with script.js. Again, it doesn't need to be a .js. As long as it's JavaScript is going to work. And that's the same thing as running it as I showed you. Okay. So with this said, let me go back to the lectures and okay, and we're going to go on with today's topic. Okay. All right. So yeah, last week I told you that we're basically done with D3 for the semester. So now we're going to look at few types of both design considerations that we haven't looked at. and more details on some specific graphical forms that are used in different contexts. So today we're going to focus on what are called statistical graphics. So those are graphics that you use for doing data analysis. That's what they're most useful for. And you use them in notebooks. So we're going to see how you, in the lab, how you use, how you create those statistical graphics in both R and in Python. Yep. Okay, so but before we get started, I'll go quickly through some basics of stats so that we understand what the graphical forms are actually going to display. And then we're going to review a little bit what statistical graphics you have to work on. So to start, statistics has to do with analyzing population data from a sample. So that's the sample is just a subset of the population because in most cases it's not practical to get all the data that you need about the population. What you do is that you work on your sample to understand it, and that's done with what are called descriptive statistics, where you find numbers that describe your sample data, and then you make inferences about the population, which you can understand as basically modeling trends in your population. So if we take the example of one descriptive statistic for the sample, that is here the mean in the picture, then you would prefix it with sample as in sample mean to contrast it with the mean that you would infer for the population. And in that case, that's a parameter that you need to estimate. Now, most of the time, you never use the sample mean. You just say that this is the mean of the data set because it's understood in the context of the data set. And this is basically in words what I just explained to you. The inferential statistics, you have different ways of going about it. One, because there are different types that of inferential statistics. And in some fields, they tend to be used more than in others. So when you do data science, you're going to do a regression analysis. If you're doing an analysis on in the medical context, for instance, what you're doing is that you're looking at understanding if a treatment is effective, and in that case, you're going to do more of hypothesis testing, where you formulate an hypothesis and then you try to understand statistically if it's going to be valid for the data that you have. In the way people refer to all these quantities that you manipulate in statistics is a little bit different in the way you refer to them in data science. So I put this table here so that there is no confusion. So usually what you call samples in the data science machine learning, you would refer to that as cases in stats. Same thing for the features and the labels. You usually refer to them as variables, and you prefix it with independent or dependent, depending if it's a feature or a label. So if you think in terms of how you would create a model that models the feature, to create to build a classifier, right? So your classifier would take as input the features and output the labels. So in that sense, the features are independent, and the label is depending on the variable. So, and hence the name of dependent variable and independent variable. Okay, it's a bit confusing, but you want to know that nomenclature because different people talk about the same thing in different ways. So here is an example that I let you, for the sake of time, play around with it, but it's obviously just to put the sentences into this functional form to decide which one are the dependent and the independent variable. In terms of statistics, so in descriptive statistics, there are a number of quantities that you usually look at when you analyze data. So measure of order is one of them. So here what you do is that you basically rank your data from the smallest to the largest, and then you give a number that is incrementing, like at 0 or 1, whatever you like, to it's 1, right? For the order that corresponds to it. So the smallest number ends up being the first order statistic, and the nth number is the nth order statistic in the rank data. The range is the distance between the n order and the first order statistic, and the modes are the number of repetitions of the data that you can see. So here you see that we have 2 modes because the 1 and 2 are repeated. Quantiles is another way to describe the data. So here you basically split the data in equal parts. So if you split in 4, then those are called quartiles. And they have very specific meaning at each one of the boundaries. So the Q2 is the median, that is the number that is at 50%. Meaning that 50% of the observation are below Q2 and 50% are above. Yeah. The first quartile is the 25, and the third one is the 75%. Yes. And as you can see, what this quartiles really boil down to is trying to understand where are most of the data into the distribution, right? In terms of ranges. So usually quartiles is what you use, but there are some applications if you want to compare your distribution of data with a normal distribution to do a statistical test. Then you would use more splits into the data. So you would compare the every 5%, for instance, to see how that fares, and we're going to see an example of that later on. Measure of central tendency. This, I think you're familiar that those are the mean, the standard deviation, and the variance. So I won't spend too much time on it. Skewness is this has to do with where the tail of the distribution is, not where most of the data are located. So this one, you see that it's left skewed because the tail is to the left, and the one on the right is right skewed because the tail is on the right. Okay, so don't get confused. It's not the tip distribution that we're looking at the maximum, but we're looking at the table to name it, to name the skewness. Frequency and relative frequency, these are often used in the form of tables. And what they are is just counts. Okay, so this is just what you usually refer to as counts. The relative frequency is the frequency divided, so the number of counts divided by the number of occurrences that you have. And that's about it. So the maths here are very simple, but these are usually useful when you have categorical data with counts to present an overview of your data, and that's usually done in the form of a table. Now, depending on the type of data, some of these statistics are feasible and others are not, and it's mostly obvious what we can do. And as you can see here, the ratio that is the data that usually you end up having with when you look at sensors and these kind of things, you can only have proportions and rate of variations with that, right? But there are more things that you can do if you have the frequency here, because you can apply it to nominal data, ordinal data, interval, and ratio. So it's a little bit counterintuitive, but that's what happens. You can do more with simpler. Statistical graphics. So why do you need to graph things? So oftentimes you think, I just want to graph it because I want to find out patterns in the data. And that's a valuable thing to do. However, the first reason is just to understand the data and to understand, and that means understanding how the data is distributed, even before finding any relevant pattern. So these are what are called the Anscombe's quartet, from the name of the statistician that came up with it. And what they show is that the descriptive statistics for this 4 set of points are exactly the same. And that is materialized here by the blue line, that is the regression line, that as you can see is exactly at the same location for all of them. And the point here is that if you are trying to make decision based on those summary, that summary information of that is provided by the descriptive statistic, then you're missing the point, because all these sets are have completely different distributions, right? So in this case, you see that that we have one outlier, and this is distributed mostly along the line. Here, the same thing, but the points are distributed in a different way from the previous one, and so on. Right. So it's always important to not just go by graphing the descriptive statistic, but you want to graph the data as close as possible to the raw data that you have. The other reason is that whenever you're doing things such as hypothesis testing, a lot of the tests, they have assumptions. They assume that the data are normally distributed. And if you don't graph it, there are tests that are done for that, but if you don't graph it in the first place to try to see if you have one mode or multiple modes, then you won't be able to do anything that is pertinent to your data. The last point that I wanted to make is that there are some of the statistical graphics that we're going to see that are only useful if the data are again matching some specific distributions. So for if we're going to look at the box plot is only able to describe distribution that has one mode. So if your data has multiple modes, then what you are going to see on a box plot is not going to be any useful. So again, the scatter plot is usually the go-to plot that people use to try to understand the data. So in this particular one here, we see that we have two modes, right? That are one here and the other one here. So we used the dots here are not filled, so that they're fully transparent. We just see the outline, and the reason is that we want to see if there are data points that are at the same location here for these two variables. If we don't do that, then we don't understand. We might miss a lot of the data, right? And that problem is a classic problem. It's called overfitting, and I have a few slides more on that to help you out. So when you have multiple dimensions, you just basically take this scatter plot and you can wrap it up into a matrix display, such as this one. So this is called simply a scatter plot matrix. And here you can compare dimension 2 by 2, because obviously we're stuck in the page with the 2D, and you remember that 3D is complicated. The scatter plot again is also useful with categorical data. In here you see an example where we're using it, and then in that case it's called a strip chart. Now here the problem is that we might have quite a bit of overplotting, right? Because this axis is for a numerical variable, and so we don't know if how many data points are on any of these dots here. Okay? So one way to alleviate for that is to use transparency, right? There are other ways that we're going to see how to do it, which include this one, that is the box plot. So the box plot, it shows the quartiles, where the median is the line that is here, the big line in the middle of the box, and the first and third quartile are here, which obviously depend on the direction of the axis. The dots that are on the side are the outliers, meaning that those are not part of a distribution that would match this extent, that is supported by this line, that are called the whiskers, and that are there to basically materialize the tails. So this is how it works out in terms of the math. So here you need to take into account the orientation that is bottom up, meaning that the smallest data are at the bottom and the larger values are at the top. The whiskers here, you see that there is a formula that is here. Now this formula, it depends really of the package that you're using. So you need to go and look up at the doc, but usually it is what you see there, that is plus or minus 1.5, the interquartile range, that is the difference between Q3 and Q1. Okay. These are other ways in which people use box plots. So again, the visual vocabulary here is very similar, right, to what we have seen. Yeah, well, the only point that I want to make is that yeah, you can look also at the skewness on the box plot. What is not that great for the box plot is understanding how tapered the distribution is. And so people are using notches for that. So and these are the notches. So the more close the notches, the steeper is the distribution close to the maximum, and the other way around. So these are box plots with notches. If you want to see the distribution, and in the case you have multiple modes, so typically here, so here I have two modes, right? Because we have these three things. If you create a box plot for this, is not the right representation because you have more than one mode. But you can do this this thing that is called the violin plot. That basically shows you kind of clear version of the distribution of the distribution, and I would say that if you're not sure of the distribution of the data, then you can do either one of these if you have multiple categories, or you can do a density distribution plot that basically just shows you the density distribution of your data. You can also mix and match. So here you see that we're doing a dot plot where we can see the instances of the individual data points together with a box plot. Okay. So the frequency, and maybe maybe I'll finish on this. Yeah, I think I'll stop because it's already 51. So we resume on Wednesday with some more of these, and then we'll work on the lab. Yeah, before I go, so some people have asked if I would allow an extension for this week, which is fine. The only thing I don't want is that you wait the last second to do it, and then we need to drag it until next Monday. But I understand that some folks have exams, right, with other classes this week. Yeah. So what would be a good time to turn in the homework for this work, the lab? I mean the assignment for this week. Thursday, Friday is fine. We do Friday. Okay. So let's plan on doing Friday, say 5 p.m. But then next week is going to be playing around with all sorts of libraries for the notebooks to create visualizations. So what I would advise is that you make sure that you take a look at the lab, that you spend the time Wednesday to work on the lab part, and then you take advantage of the office hours with the TAs Thursday and Friday to make sure that you can deliver for the next week. Okay. So otherwise we're going to move things again by a week, even though this is going to be the last assignment, the one that has to do with this week's material. Where the 10 is the X. Is it? Yeah. There are two more. Okay, I need to look at the schedule, but yeah, my plan is to give you at least 4 weeks to work on the project. So we can, and we're going to make assignments for the project. But eventually we're not going to grade them, but we're going to grade the project itself. Okay. Yeah. All right. Thank you.